Let's be honest. Does PySpark ever feel like some kind of dark art? You're not alone. But what if the secret to mastering it wasn't just about memorizing code, but about adopting a new mindset? In this explainer, we're going to pull back the curtain on PySpark and show you how to think like a practitioner to solve real problems. Let's jump in.
So here's our game plan. We're going to start with a tool you might not expect, good old pen and paper. From there, we'll get our hands dirty and take a first look at some data, then use it to answer a real question. After that, we'll talk about writing code that actually lasts. And finally, we'll zoom out to see the bigger picture of what it means to think in data.
All right, first things first. Before we even think about opening a laptop or writing a single line of code, we've got to get our heads in the right space. And it all starts with the practitioner's mindset. I know, it sounds a little crazy, right? We're talking about this incredibly powerful big data tool, and the first piece of advice is to grab a pencil. But trust me, there's a really powerful idea here. By sketching out your plan on paper first, you force yourself to clarify your thoughts. It helps you see the whole picture before getting lost in the details, and it will save you so much time later.
Okay, mindset, check. Now it's time for that moment every data person knows and loves. It's that hello world moment where you've loaded your data set and you get to take your very first look inside.
We've all been there. You're so excited to finally see your data. You run the command, you hit enter, and what you get back is just a mess. A wall of text that's been cut off. It's a super common roadblock. But don't worry, the fix is incredibly easy.
I mean, look at this. We're trying to analyze a book, but all we can see are these frustrating little dots. Dot, dot, dot. How are you supposed to understand your data when you can't even read the first sentence? This is a classic first-time using PySpark problem, but the solution is so simple.
The good news is the solution is built right in. The .show command has these little options you can use to take back control. You can use n to tell it how many rows you want to see, truncate to stop it from cutting off your text, and vertical to flip the whole thing on its side, which is amazing for really long records. And boom, just like that, with a couple of tiny adjustments, that messy, unreadable output is now something you can actually work with. It's a small win for sure, but it's a huge step toward really understanding and controlling your data.
So now that we can actually see our data properly, let's make it do some real work. It's time to ask it a question and see what answers we can find.
Okay, here's our challenge, and it's a real-world problem from the book. We've got this huge data set from the Canadian Broadcast Regulator, the CRTC, that logs TV broadcasts. Our mission, should we choose to accept it, is to figure out which channels are hitting their viewers with the most commercials.
Every good investigation starts with the evidence, and here's what we've got to work with, a look at our data structure. We see a bunch of IDs, producer names, languages, but wait a second. There's no column here that just says commercial. So how are we supposed to find our answer?
Well, it turns out the clue is hiding in plain sight. We can use a simple function called substru. Think of it like a little magnifying glass that lets you pull out just a few specific characters from a long string of text. And that's the key to cracking this whole thing open.
Okay, so we found the answer. Awesome. But our job isn't quite done. Getting the right answer is one thing. As a real practitioner, you want to write code that doesn't just work today, but code that lasts. Code that other people and your future self can actually understand and rely on.
And this right here really gets to the heart of it. There's a world of difference between code that just works. It's held together with duct tape and hope, and code that's truly robust and professional. Robust code is easy to read. It works every time, and it doesn't just crash when something unexpected happens. This is the level we want to get to.
Now, when you first look at a line of Python like this, you might think, whoa, what is all that extra punctuation? What's with the colons and the little arrow? These are called type hints, and they are an absolute secret weapon for writing bulletproof code. Let me show you what I mean.
It's way less complicated than it looks, I promise. That first part, frac, is just a little note telling us this function expects to get a fraction. Then we define what a fraction is, just a pair of two integers. And that arrow, that just tells us what the function will give us back. Either another fraction, or maybe nothing at all. See? It's like leaving helpful instructions for your team.
And this is the magic part. When you use type hints, you can run a tool like MyPy that checks your work before you even run the code. It acts like a proofreader. Look at this error. It caught a mistake. It's telling us, hey, you tried to give me text, but I was expecting a pair of numbers. This is a total game changer for writing reliable code.
We have covered a lot of ground, from pencils and paper all the way to advanced Python code.
For our last section, let's zoom out a bit and talk about the bigger philosophy of what it means to work with data.
I absolutely love this analogy from the author. He's bilingual, and he says that just like some ideas are easier to express in French, some are easier in English. And it's the exact same thing with data. Some problems just feel like they should be solved in Python. Others are a natural fit for SQL. The real skill is knowing which language to speak for which problem.
And that really brings us to the ultimate goal. Whether you're using Python, SQL, or even that pencil and paper we started with, your job is to express your ideas clearly. You're always communicating to the computer, to your future self, and to your colleagues. Clarity is everything.
And that's how you really build your data intuition, by going through this whole process, taking notes, exploring, making mistakes. You start to develop a feel for it. You build this gut instinct that guides you, making you a faster, more effective, and more confident practitioner. It's like developing a new sense, a data sense.
At the end of the day, learning a tool like PySpark isn't just about learning syntax. It's about learning to speak a whole new language, a language that gives you the power to ask new questions and find answers you never could before. So the only real question left is, what problems will you solve?